and then one of them is going to be n minus let's say 5 and n minus 3 or plus 3.
Okay, plus 3. Let's see. Okay, close.
I think.
Yes, close. Now,
did I flip the signs?
yeah, you see when you do the try and error, you do the first.
Two, yeah.
Yeah, you do the first to get the n
They're both
squared.
negative.
Okay, you got it. You got it. So the last, you could kind of like not worry about the sign that much. It's like, hey, 15, get the combination like 5 and 3. And that 5 and 3, if you can add or subtract like same sign or different sign or subtract, and you get this 8 somehow. Don't even worry about that, the negative 8. You can actually kind of modify the sign later on. So this is it. And you cancel this thing out and you're done. Now, I noticed that you have and this will be the answer, but you also want to state the domain restriction. What that means is, what that means is that it's just the denominator that you have to state, hey, n cannot be 5. That's it. Like, that's the restriction. This is the answer, comma, that. Like, I'll write it together. So it's n minus 3 is the quotient or just what's left. And then n equals 5, and not equals 5, the restriction. There you go. This is common, okay? This is normally the way they do it with the slash through equal sign. Yeah. Okay. So same idea for the top. You could also do the restriction right off the bat if you want, like this here. You could. I know that it's stated later on, but you know what? Let's do it after, because it seems like after you factor, it becomes clearer. Like, yeah, let's do it after. So okay, let's see 12a here. And then for this one, what's the greatest common factor? Let's see, you're okay with that.
The greatest common factor is going to be 3a.
Yes, yeah, you got it. So it's 3a times what will give you 9a? It'll be 3a.
Times 3a.
And plus 5. Is that okay?
Yeah.
Okay, good. And then you could, cross cancel here. And then 3 can go into 12 4 times. So let me be neat here. And it's stuff 1 time. Therefore, this is what you have left. 4 over 3a plus 5. Now, the restriction, you should be writing for both of the factors down here. So what I mean by that is that 3a should not be equal to 0. A, therefore, you divide both sides by 3, but you still keep the not equal sign. So the first restriction would be that. And then the second restriction would be this one. It's like you said it not equals to 0.
How do you know if there's multiple thingies?
Okay, good. Good question. The denominator, if you can factor and you can set each of the factors equal to 0, well, not equal to 0, then that would be the restrictions. Those would be the restriction. So in this case, you got, like 3a, that's a factor, right? Like when you factor out, and you got another factor back here. Therefore, you got 2 factors. If other factors can be set equal to 0 or not equal to 0, therefore you want to try it. And that's how I got this. And now we're going to get this one. Subtract both sides by 5, divide both sides by 3. Is that okay? Like, see how fast? So there it is. Do you remember something about this? Okay, I know exactly where it's going. I was going to say it. I forgot. You're going to be graphing this thing too. That means if you graph this, you're going to have to deal with the denominator either being, for example, a vertical asymptote. Know something about that? Yeah. Or...
No, we start vertical
Yes.
asymptote and horizontal asymptote.
Okay, good. But this one, for example, here, a can be crossed out with, something. If something is crossed out from the numerator and denominator, this a not equal to 0 will not be the restriction. It will not be the vertical asymptote. It would be a whole or removable value or whole. The graph, when you graph it, it'll make sense that, there's a graph that goes through like this, and there's like a little gap. You won't see it in calculator, but when you actually try to figure out what that is, you punch in the calculator, there'll be an error. So it's coming up. So this is one of the big concepts that can get confusing a bit. So don't worry at 0, for example. So this one is called a removable whole or just a whole. Yeah. In the graph, you'll see when you sketch it, you actually have to find literally the x and y coordinate of that whole, like x comma y. But the way you sketch it, you just put a circle in a little gap like that, like I just did. So that's how you're gonna deal with it later on. So anyway, this will be the restrictions, and this will be the answer. Double check, yeah. Okay, and yeah, continue with this one. I think this is pretty easy. Just 5x minus 1, factor the GCF, and then you got x minus 1. And you cancel that. And then you do, hey, domain x cannot be 1 because you set this not equal to 0. Is that okay? Like opposite.
Wait, why can't it be 1?
Because the restriction is that you cannot have the
Oh,
denominator.
because the thing. Yeah. Okay.
Right, the denominator.
Okay.
Yeah, if you do use 1, it'll be undefined. It's an asymptote.
Yeah.
Oh, yeah. I'm sorry. This is a whole again. You see, this is okay. Since we're seeing it quite a bit, if you ever cancel the denominator with the x in it and the numerator, it will not be an asymptote. If we have time, we come back and I'll sketch it and I'll show you what you won't see the actual pixel or a little gap around it, but there's an error when you're trying to find it. You'll see. So so this is going to be the restriction. And don't forget the answer is 5. And the restriction there.
Oh, yeah.
Okay, this one, same. Oh, here we go. This one is the fancy one. The numerator, r cubed plus 8. Do you remember? Is the sums of
And
the
oh
sums of
yeah, the
cubes. Yeah. So let me write out the formula for you, just for a reminder. So it's this thing that is this here that you have to come up with. So it's a plus b, a squared minus opposite here, same here, opposite here, and then always plus. But let's see here. Yes, so this one here it will be always plus. I think AP soap. I guess there, right there.
Mhm.
If this were minus, there'll be minus here, and then it'll be plus here for the other one. The difference of cubes. So anyway, so therefore your R. This is your A. R is your A. 2 is your B. So therefore it's
Okay.
going to be. So I got A plus B here, and then you're going to do A squared, which is R squared, minus A times B, which is the same thing as 2R, plus B squared, which is going to be 2 squared, which is 4.
Why would it be 2 rather than 8?
Okay. Okay, I let me rewrite it. Good question. I skipped a little bit of a step. So if you were to rewrite this, it'll be R cubed plus 2 cubed. You see how you have to write it
Oh
into
yeah.
the cube. So that's why your R is going to be A and your B is going to be 2. There you go. Yeah, so this is, you rewrite them as your A cube, B cube form. And then you know your R, your base is 2 for B. Okay, so the denominator. Now, one thing you always want to know, if you ever apply the sums or difference of cubes, your trinomial back here, you just make a note right now for all your your cubic going forward. This is not factorable. Okay, but it doesn't mean you cannot solve it. If you were to solve it, it will be an imaginary. You remember the I stuff? So it's not factorable. What that means is that when you're simplifying, you can never actually try to cross cancel with the denominator. So you don't waste time doing that. You know what I mean? So the denominator
Mhm.
can be factored, but you'll never mess with this one. You're not going to be, crossing something out from there, or like or like you might be thinking there are two sets of binomial that you can cancel or something. No, it's not factorable. So just make that note. So not factorable. So that's going to save you time, because you might be pondering over, hey, should I continue? Like right here? No, you cannot.
Mhm.
But you can solve because you already work with imaginary numbers, so complex numbers. So you don't have to. You have to deal with it, but not yet, not yet. So anyway, what is this? What about? Oh yeah, let's go for it.
R plus 5 and then R plus 2.
Okay, good job. And the signs?
Plus and plus.
Yes. And therefore we cross out there. So there you go. And this is going to be the whole at -2, by the way. I forgot to mention. Okay, what about that whole value is opposite? Again, just like you said it, not equal to 0, it'll be -2. But don't worry about it. But you're going to write not equals to -2 and -5. Is that okay? Like you're going to set each one not equal to 0? But let me write them independently. Let me write
Why
let me
does
write
it
seven.
not equal -2?
So okay, let me backtrack. You're still gonna, how you factored them and you still got the 2 factors on the bottom? You have to set them each one not equal to 0 and then solve.
Oh, both
both of
Oh,
them.
okay,
Mhm.
okay.
Yeah, not
Even
equal
if you
to
like
0.
get rid of it for the final
Yes,
one.
even if
Okay.
you cancel them, yes. So r not equals to -5, and r not equals to -2. Okay. All right. Same, moving on here. Now, I assume you may be okay, but I want to look for something more tricky, trickier, like 7 maybe. But I think you're going to be okay with this. Do you want to try? Yeah, let's try the numerator.
X minus 9, then X plus 7,
7. Okay,
right?
almost.
Almost. Did I
Mhm.
flip the signs?
Yeah, do you know how to check it? What you do is that, how when you FOIL it, you do outer, inner. If
Yeah.
you combine the outer and inner, it has to be a positive 2x. So if you do the outer, you get
Oh, yeah,
7x,
yeah, yeah,
and
yeah.
then you get negative 9x. You see that? So that means if you were to combine them, it'll be a negative 2x, but you want a
Okay.
positive 2x. So you got to
Okay.
switch the sign. Yeah. So yeah, the combination you got down pretty good. You have to double check your sign, and also double check the sign of the last. The first outer inner or first outside
Mhm.
inside last. It has to be negative. Negative 63. So yeah, this works. And the denominator, might as well. Let's do it.
X minus 7, and then X minus 1,
-1. Let me see. Minus
right?
1. Yes. Is that okay? If you do
Yep.
outer, if you do outer B, you get your negative x. You inner negative 7x, therefore negative 8x. Good. Very good. Got it. Then cancel. But then you got to do the restriction again for both. It cannot be negative. Oh, positive this time 7. X cannot be 1. Okay. Very good. And let me see. I shall we look at? I think you may be okay with 6. Let me see. Shall we look at 7, 8? Okay.
Sure.
All right. What's the GCF for number 7 here?
Um, it's gonna be 5, I'm pretty sure, in B.
5B. Yes. And 5B times 4 will give you 25B. It'll be 5B again.
5B, 5B,
And then,
uh,
and plus what?
2.
2. Got it. Okay. Very good.
And
And denominator.
bottom's also gonna be 5B.
5B,
Then it's gonna be 3B
3B,
minus 1.
1. Yep. You got it. So they both cancel
Can
here, right?
okay, you can cancel that.
Yes. Now, B cannot be equal to 0, and B cannot be equals to 1/3. You see that? Is that okay?
1/3? Because,
Yes.
oh, yeah, yeah, okay,
Add both
okay.
sides, yeah. Add both sides by 1, divide both sides by 3. So that's the restrictions. Those are the restrictions there. Double check. Yeah. So don't forget to write your final, what left over, right? Whatever
Yeah,
you
no,
got.
I've
Yeah.
been doing that.
Okay, good. Some teachers don't mind, look, this is like college kind of writing, like you want to move on fast and just leave but yeah, so teachers are okay, pretty lenient about what, you keep, what they see left over. Okay, the numerator, this one,
Sorry. The numerator will be 2 and 7, or x
I mean,
um
M, right?
or m.
2 and
Sorry.
7. Okay, let's see. What about the sign?
What are their thingies? Their signs are gonna be a positive 7 and a negative 2.
Yep, you got it. Now, the fancy one at the bottom here. We
Um,
we want to do GCF first. Is that okay? Now, if you want to save some time, you can write it somewhere else so that you don't have to do like something here and then you got that and you continue. You see what I'm saying? Like that. Like you're gonna
mhm.
continue. You could kind of like, yeah. In college, they tend to write it here. Like a little bit like, and then they can look at the trinomial later. So let's see. Let me show you where I would do it. What do you think the GCF for all three?
Um, m to the second and just m to the second.
Mm-hmm.
No, I'm so stuck at plus 16m
Mm-hmm. And
plus 63.
yes. So from here, now you could just like do this. So just like somewhere out, to the side. I mean, it's not a big deal. I mean, you can write and show the step, but if you were to do it, you have to copy this again. Imagine that. You know what I mean? Now, there's more to it. You can also write it here and then write it below it. You see that? Like go scratch it right below it. Then you can cancel it. But sometimes it's a little distracting if you do that. But it's up to you. You can do it in any way you want. You could rewrite. No biggie. Okay, what about continuing on here? Well, this can be factorable into two factors.
Um, uh, I don't know about this one.
Okay.
My 9 tables or not,
Yeah.
whatever. I don't
Okay.
know.
Okay. Now, uh, 9 and what?
Oh, I was gonna say 9 and 7, but I know that doesn't equal 16.
Okay, it is.
Oh, really?
Nine plus 7 is 16, right?
Actually, wait. I was subtracting. I don't know what I'm doing.
Right? Yes. So 9 and 7 plus plus. Okay. Yeah. And then you can cancel the m plus 7, and whatever you have left is that. However, when now you see this m squared, that's still the restriction. If you set m squared not equal to 0, it's still you can still solve it. So m cannot be equal to 0. Also, you can think of it like there are two m's on the bottom here, like timing each other. So each one cannot be equal to 0, but they're the
And
same.
M
Therefore, you just write one m not equal to 0, like that.
is there 3 M's?
Yes, there's three m's. So m not equal to 9, then m not equal to negative 9, negative 7. Now, sometimes they put commas, like instead, just write one M and not equals, like three of them. It's up to you. Yeah, you can do like M not equal to 0, comma, negative 9, comma, negative 7, like that. Some people do that. Okay, you got this. Let's see what's so fancy about this one. I even want to look for the
They just
head
look
here.
scary.
Yep. Okay, I see that number 7. I see finding the mistake, but okay, we'll get to that. Let's see anything fancy here. They're not bad. Oh, got it. There's a 4 term right here. Okay, 13. Let's do 13 first, and then we'll go around it. So 13, there's a 4 term that you have to factor. Do you remember how to do it?
Oh, it's like you cut it in half, and then like you have to do the first half and the second half. Right?
Yes, that's right. I've seen some teacher would do some step like that. You don't have to. It's I don't know. This to me that's just kind of distracting. Just go ahead and like cover up the last two. Look at the first two, and then once you finish the first two, then cover up the first two and look at the last two. Like eye it. So, okay, what I mean is have a look. So let's do the first two. What is kind of focus on the first two? What is the greatest common factor?
2t
2t
to the
squared.
second,
Yes. And then yes,
3t plus
3t
4.
plus 4. Good job. Now, continuing on here. Okay, continue on. If this is a plus right away, this will have to be a plus. Okay, if this is a plus, this has to be a plus. And then now your eye should be away from this, and then just look at what is the common factor between these two here. What do you think? That's a fancy one.
1.
1. Yep, 1. So you write 1, and then you write 1 times 1 will give you all that back. It's a positive 1, okay? So it's positive 1. Oh, it's just going to be everything like that, right? Itself,
Yep.
all of that back. Now, if you do this correctly, right, the numerator, I know I wrote this, but this one just be neat, I guess. I know we're going to write a lot. Now, if you do it correctly, the factor, these two must match. If you do it wrong,
Yes.
it will not. Okay, I think you remember the pattern now. So that's done, but we'll collect them, we'll group them, regroup them. But let's do the denominator being consistent. Okay, common factor or
That's
not?
the our common factor is going to be
There
just
isn't. There is no common factor. So
what?
that, but is there something that that you recognize? There's something special about this,
It's
or
the
if not,
square
just
be the three thing or the two things in the bracket and the three things in a bracket, right?
okay, not quite because
Oh.
it's a square. So yeah, how
Oh,
about
does that
this?
only work for cube?
Yeah, it's only for cube.
Okay.
Yes, be careful on that one. There is a formula for this one, so I'm not saying it quite yet. I just want to see if you remember how to factor it. How would you how would you write it out, like the factor, or is it something that you're supposed to do first?
I don't remember.
Okay, so this denominator, if you recognize 9 and the 16 to be perfect squares, that means you have to apply the difference of square formula. There's only a minus, okay? There's only the difference. There's no plus. There's no such thing as a plus one. So if you remember, a squared minus b squared is the same thing as a plus b, a minus b. It doesn't matter which one first. You can do a minus first. You recognize this? The difference of squares. So this is the one that you're about to apply here.
Oh.
Now, just be mindful that there is no such thing as the plus version. Only the cubes, like the sum or the difference of cubes. This is the
Mhm.
difference of squares. So how do you come up with the a and the b? Well, some people don't even write anything, they just go ahead and write out the combination or the guess, like, hey, what times what will give you that back? What times I will give you that back? But some people do like what the textbook used to do. I don't think you guys use the textbooks anymore. So let me show you. The textbook would write this to show how it works before you apply it, before you apply the difference of squares. So they would write the a and the b form in the parentheses. Here, 9t would be written as 3t squared. There's your a. And then the 16, well, the 4 will be your b. Sometimes they even size it with the parentheses around it. So there's your a, there's your b. So therefore, if you apply the a and the b in here, you can kind of see it already. It's like, hey, 3t plus 4, 3t minus 4. See what I'm saying? 3t plus 4, 3t minus 4. Just like that. Some people don't even bother gathering or just like rewriting it. They just see it. They just go ahead and, hey, what's the perfect square times itself? Like the perfect square term, 3t, 4, 4. But you got to make sure the signs are opposite in between. Do you recognize it? You recognize it?
Yes.
Yeah, the easiest one is this, that when you start learning, is something like this, 25, when you start learning for the first time. X squared, minus 25, it's going to be x plus 5, x minus 5. This is just an example. So this is the one that I think you like recognizes right away, something like this.
Mhm.
So it's the same thing, but it's more to it, like 9 is 3t, like that.
Mhm.
Imagine, yeah. So there you go. But then I don't like the arrow here. I can't backtrack either.
Can you cancel out all three of the
Okay, not
3t
yet.
plus 4?
Yes. Yes. Do you have to actually? We didn't regroup this yet. Let's do it.
Oh.
Yeah. So we gotta
Oh.
regroup them. So if you remember, this arrow is distracting me. When you have something, when you do it right, you have this common. You must have it common. If not, from coming for four term polynomial here, right? You got to make sure they're the same. And once you got it, you either write that once somewhere in the front or in the back. So have a look. I don't know. I would write it in the back, and right in the back right now. Okay, let me gather that. So one time. So it's 3t. And let's zoom in. 3t plus 4. And then what about the front? You have to bring in the 2t squared plus 1 here together. So it will look like this. 2t squared plus 1 in the parentheses. You recognize that? I hope. It's like you bring that in, you bring that in. Now, there's reason behind this. It's called distributive property, but a lot of students can't see it quite well. It's a little bit kind of odd because the C or there's A here. Let me show you. It's like something like this. Your C is when you distribute, right? It becomes CA or I write it the way they would write it: AC plus BC. Like that when you distribute, right? So your C is technically this whole thing. So you're distributing it in there, like that. And when you do, it will look like that. But I'm gonna guess that may be something also kind of like what to you, right? Yes,
Kind
right.
of makes
Yes,
sense.
it is. It's just that your C is it's a binomial stuck together as a group. You know, But then when you distribute, you don't literally write anything. You just attach them in the front, like here, or in the back of this, or in the back of that, in this case. See that? But you don't necessarily go back and distribute them further yet. You don't have to, because you just want to factor. So this is it. Now, if you just want to make it simple, just go ahead and write this once together, once, and then write the other pair in one, in grouping, in between the set of parentheses. That's it. I hope we can have another one. I think this is going to be the one that you want to know. Oops, for sure. Okay, so I'll be able to make up one, I think, before we. Okay, anyway, continuing on. I know I'm trying to erase this arrow is distracting. Oh, and I can't. Oh my gosh! But you can see, right? This is the yeah. Okay, copy it down, and then we'll be neat here, and then we'll cancel what we can. So you can only cancel the plus one.
One.
Yes.
Yeah.
Therefore, the leftover. Yeah. Now you might be thinking, hey, can I factor this one? No, because it's not the difference. It's not subtraction. And moreover, this is not like a 4. If this were a 4, then it's going to be factorable. I'll show you in a second here. And then this, of course. But then you got to write your restriction again. So this is the answer, but then you're going to write the restriction. Something like, right, comma there. T cannot be. I'll do this one first. Subtract both sides by 4, divide both sides by 3. So it's going to be negative 4/3. And I'll do this one here. Same thing as this one here. Add both sides by 4, divide both sides by 3. So it cannot be 4/3, plus or minus 4/3. Is that okay?
Yeah. Yeah.
Okay, good. So these are the restrictions. Even though, I'll point this one out again, the one that you cross out, but the value of that is the negative 4/3. Is that okay? You see that, right? But it's a removable. This is a removable hole, or just sometimes it's called removable in the graph. So be aware later on. So yeah, when you start graphing, this is going to come in. But I guess not yet. Okay. Oh wait, I was saying something about this. So if this were in the numerator, I'm making this up. Minus here. Do you want to try to factor this? Pretend this is like, hey, something that you're going to deal with. Maybe here, So you want to try to factor this one? It is factorable. It's like a test one. I see more like a test one.
Well, is that gonna be T and T? Well.
Yes, there's more than
Oh
that.
wait, it's gonna be 2T times
Yes.
2T.
And then what?
There's gonna be a 1 and a 1, I'm guessing.
What are the signs?
And 1 is negative and 1 is positive.
Yes, doesn't matter which one. Now, how do I know this is going to work? If you FOIL this, the outside inside will cancel. And then the last will be a negative 1. You see that? And the first will be 4t squared. See it? Try to mentally FOIL that. This is it. So this is like, it's a little tricky looking, right? You might not pick up on it that it's factorable, but it is. So be aware. This is like a test type of problem you could easily get. So yeah. And then the denominator may have one of these, you can cancel. Imagine that, right? So just, kind of look out for that. So why? This is a perfect square number, and 1 is also a perfect square number, because 2 times 2 is 4, 1 times 1 is 1. If you ever identify perfect square number and a minus in between, they're factorable. So just, it's a difference of squares. So you gotta look out for that. Okay, I see that. Oh, see, this one is, since we're working on that, might as well do this one right away. So what is the denominator?
It's gonna be parentheses W plus 8 and W minus 8.
That's it. Doesn't matter which one first. Now, there's something here. Every time you do this, there's a pretty good chance that the numerator will have one of these factors in it, so you can cancel. Can you imagine that? Because we've been doing that. So if that is something can be helpful to help you actually factor this, you might as well look for it So let's do this now. But I know I've been I giving you a hint, but then I want you to ignore what I just said because I want to see if you know how to factor this. Because okay, what's so special about it? Because it has the coefficient of 3. Yes.
Yeah.
How would you do it? Let's see. Ignore the denominator if you can. Yeah, it still can be
Uh,
factored like this. Oh, first, of course, you want to look for the GCF, but you know there's no CGF. So that means you go at it right away. How would you do it?
um,
So I have not worked with you on this. I know that we, factor, we just go along, just guess the combination, but we never work with anything
it's gonna
with
be,
other than one coefficient.
so, I'm trying to,
Okay, so here's how you can do it. You can still apply the guessing or the try and error, which is what college students do. Nothing else. No kidding. If you have to deal with factoring, you don't want to do this X thing. If you don't have to, it will waste. It will it will extend. Oh my gosh, you expend a lot of energy doing that because you have to do some grouping if you were to do it with this 3 or anything other than 1 in the front. So you have to continue further. Yeah, there's a couple like one at least one more step further than just this. But let me kind of guide you through it. You're still gonna do the first. You're gonna guess the first combination and the last, no matter what. So you're gonna do a first and the last
well, one
combination.
of them's gonna have to be 3W, and one of them's gonna just have to be
Yes.
W.
So that's good job. You tend to want to write the bigger one up here and then the smaller one back here. Is that okay? It's just the way they
Yeah.
computerized. Yeah. The solution, if you're going to see it, there's going to be the 3 in front here and the W back there. 3W and W. Now the 16. I know you have several combination, but here's the most common combination that will work likely. I'm not saying it's all the time. It's like pretty good percentage,
Oh,
60, 70%.
um,
What do you think?
one of them's gonna be, the one not with the 3W is gonna be 8. For sure.
Oh, okay. You mean like back here?
Yeah.
Okay, now 8 and 2 then. Yeah, gotta be 2 and 8, 8 and 2, right? But
Yeah.
I want to mention something. There's a good chance. I'm not saying it's going to be for this one, but it's high percentage. The last that you're trying to find for the combination for the last, it will be the number, a product of two numbers that's close to each other. That times when you times them, right? You're gonna get a 16. So what is the number that's close to each other? It will give you 16 besides 8 and 2. Let's go with that first.
Um, 4 and
4 and
4?
4, 4 and 4. So let's try that. Now, how do you, well, even ignore the sign. Here we go. You're going to do the outside and inside. Let's check. Outer is 12W.
Mm-hmm.
Inside is 4W. Can I add or subtract to get the 22? No, right? Not this one?
No.
Okay, so that means no. So I know I wanted to point that out because most often it does work. The number that close to each other. So the 8 and 2 is a bit further apart. So, but it's going to be 8 and 2. So you
And
get
it's
your
a negative
combination.
8 and a positive 2.
Okay, but where do I write 8 first? Do I write 2
So,
first?
it's plus 2 first, and then minus 8.
Okay, so minus. Let me see.
Or it's a minus 8 and then a plus 2, I think.
Okay, yes,
Right?
you got this. The outer is negative 34. Oh, no, I'm sorry, 32. Oh no, it does not
What?
work. Yeah. So
32? Oh,
yeah,
wait,
so
I
you
thought it
got
was a 2.
yeah. You can look at it. A 32W, and then you got a 2W. If you
Yeah.
combined, you're not gonna
Yeah.
get yeah.
No, I thought that multiplied to 24.
Uh-huh. So oh no, wait. You're
Yeah,
right.
it is 24. Wait, no,
Yeah,
no.
no. It is 24, negative 24, and inside is going to
Okay.
be right.
Minus
I'm
2
sorry, it's
and
8 times
negative
3.
22. Okay,
Yes.
so that's right.
Right.
Yeah,
I don't know
yeah,
where I
yeah.
got the
Okay.
4. I see the 4. I don't know where I see the 4. Yes, and then negative and a positive 2W, right? So
Yes.
yeah, if you combine them, yeah, this is the combination. And as you can see, you got one that match, the numerator and denominator, you match it. They cancel that. Okay, good job guessing. I got that one wrong. Very good. But oh yeah, I still want to kind of point out, okay, most often get the number close to each
And
other first. Yeah. Now you can exhaust the
then
whole combination.
x,
Okay, what do you
then
got
x
left?
can't be 8 and negative 8,
Yeah,
right?
you mean W? Yes, W cannot be
Or w.
cannot be
Yeah.
8 and -8. Yep, that's it. And then keep the leftover here. Yep.
Yep.
Okay, very good. All right. What do you think? What do you think? What do you think? Um,
Um, Can we do the fix the mistake? Because I was staring at that one for a while and I didn't even know where the mistake was.
Oh, I see. Okay, let's see. Okay, you could technically do this without having to write this, right? Okay, let's see.
Mm-hmm.
Imagine you I the first two. Okay, you factor. Okay, I can see that this is fine. Then you I the
Yep.
last two. Yeah, remember how I mentioned if this is negative, this better be negative. So the common factor between 15 and 40 is 5. Yeah.
Yep.
Okay. Then check 5 negative 5 times 3 is negative 15, negative 5 times or the 3x negative 5 times negative 8 40. Okay, fine. All right, then and you gather this and you put it here and you cross cancel
Mm-hmm.
that. Okay, so I see the error. Okay, you have that left, but it's in the denominator, right, Karen? The numerator has to be 1.
Yeah.
That's the
Oh, so
error.
it's over.
Yeah. Is that
That's
okay?
weird.
Yes. So that's
So how would
interesting.
I explain that?
Okay, you explain that.
That's they forgot.
Yeah. You have to say that, hey, there is a numerator. The 3x minus 8 is in the denominator. That's it. You can say something like that. But then you can show that what's in the numerator is 1. You can show the full final answer. You got to rewrite. So that's wrong. Then you rewrite it. You could, everyone will say this differently. You can say however you want. Just kind of like go on your own there. Just saying that, hey, it's not 3x minus 8. It's 1 over 3x minus 8. The restriction is right. Like you continue here. The restriction. Is that okay? Oh, look at this. Oh, look at this. This is what I mean. Check this out, okay? I didn't realize that. I thought it was coming from a 4-term trinomial. Check this out. We were saying that for the last problem,
Mm-hmm.
you don't want to try to actually do the x thing. And guess what? They did the x thing. I know you don't see the x, but what they did is this. This is the grouping method. They call it AC grouping. You would multiply this times that, which is
Mm-hmm.
120. Okay, 120.
Mm-hmm.
Okay, so 120, and you have to come up with the combination of all the factors of 120. You see that?
Mm-hmm.
This is the methodical way. If you don't have to do this and you can guess the combination of this to that right away, I recommend you do it. You see
Okay.
that? But they went
Mm-hmm.
and do the grouping method, which is very methodical especially when you have a number other than 1. You have to do this particular, pattern.
Mm-hmm.
You have to come up with a pattern that works, or they come up with 8 and 15 that they put in between right here. Yeah,
Okay.
8, yeah, negative 8, 15. You'll be to get you a negative 23. Do you see that?
Mm-hmm.
The combination that combines to give you negative 23. So look at that, all that. But if you were to guess, you'd be done before you even reach there. Yeah.
Mm-hmm.
So anyway, they show all of it. So it's up to you. But could you try to imagine you can do this by
No,
guessing
yeah, yeah.
right? You see it? Yeah, like the outer got to be, something inner, got to be something to add up to be a negative 23. So I recommend you go at it. And you're always likely going to get it fast. Okay, what else do
Mm-hmm.
you think?
Do you want to do 16 and then just like go down the
Okay,
list?
all right, 16. All right, let's do it. Let's factor. This is good for practice. Okay,
Um,
good job. You picked the right, rational expression to work on because you got a 3 in front, you got a 4 in front here. Okay,
mm-hmm.
first just look for the GCF, but there isn't. Is that okay? So,
Yep.
all right, what combination do you want?
It's gonna be 3y and
Mm-hmm.
then something something and then
3y, 3y.
y.
And why, huh? And what? So when you do try and error, you always guess the first and the last. And we got the first right here. Now just guess the last. The last to get you negative 8. But you don't, normally if I can recommend it, don't worry about the sign. Don't worry about the sign. Just go ahead and get the combination like 4 and 2, 1 and 8, But where we want to put them, that's all. You want to put it here or
I
here?
think there's gonna be a um. I don't really know which one's negative or positive yet,
Don't
but
worry. Don't
there's
worry.
gonna be in the first parentheses.
Uh-huh.
There's gonna be a 4, and then
Okay.
the second there's gonna be a 2.
Okay, so here we go. We're going to test it. The outer, it'll be 6y inner. It'll be 4y. Could you see that you will get a 10 if you add them, right?
Yeah.
So that means, how do you get the negative 10? Well, I should not have written. Okay, one more time. 6y and a 4y here. So you got to have minus minus here.
Oh wait, maybe it's a 2 in the first one and a 4
Wait,
in the
wait,
other one.
wait. It's the combination. Okay, okay, this is good. So wait, let's try it so that you know all the possible combination if it's right or wrong. So you know how you went 6 and 4. Is that okay? 6 outside, inside is 4. You know you can get a 10, but to get a -10, you have to do minus minus, right? But
And
it doesn't
then
mean
that's
it doesn't mean it's going to be the answer yet. But how to get the minus coming from here? It had to be from here. Or you got to put a minus
yeah,
in front of the 2. And how to get a from here? You got to put that minus here too, right? Like that.
yeah.
Now, sure, it will give you the outside inside combined to be -10y, but the
That's not gonna
last
get a -8.
exactly. So you got to come up with another combination. And so we want to see like what could be possibly wrong also, just in case you might have fell for it. You know what I mean? Yeah.
Mm-hmm.
So it's not 4 and 2. What do you think?
Um,
Wait, I'm not
it's
saying it's
gonna
not
be
4. I'm not saying it's
it's
4 and
gonna
2.
be it's gonna be a +2 in the first parentheses and a
Yeah.
-4 in the
There you
second
go. Now let's
parentheses.
test that. So we're gonna get a 12 outside. Inside is 2. Is that okay? 12y, 2y. So now we need a -10y. So I need to have a -12y, right? So that means it has to be
Mm-hmm.
minus here and then plus here, right? Is that okay?
Mm-hmm.
That's it. So this works. We still use the 4 and 2. Okay, good, good, very good. Let me go ahead and, oops.
What about the bottom? Is
What do you
that
think? Yeah, let's do it.
factor?
4 and 2. Okay, what combination do you think you should do? Again, you should look for GCF, but
Well,
there's
it's
no
gonna have to
GCF.
be 2y and 2y.
Okay, 2y and 2y. Now,
Um,
check this out. I'm not saying this is not. I'm not saying this is going to be wrong, but since you already did the numerator, okay, so you know how you always been able to cancel something else. So that means you should not do 2y and 2y. I did mention that. Yeah,
so,
you should get a number close to each other.
okay.
So that means you
So
should
it's
do it
gonna be 4y
y
and
and
y.
y, and then you know this is going to be -4, right? Do you see that?
Yeah.
Because there's only y. Now this
So then it's
helps
gonna
to
be
speed things up.
+1.
And this is a
Oh, okay.
+1.
Then it's just gonna be +1. Yeah.
Yes. Does it
And
work?
that
Yes.
crosses out.
It's
That crosses out.
that's it. -16. Yeah. So cross out, cross out. That's it. So therefore, whatever you have left is the answer. But then we're gonna write the restriction. So y cannot be
And
what?
then it can't equal +4,
Okay.
and
And
it can't be -1/4.
that's it. Okay. Got it. Good job. Should we work back? Oh yeah. Let's work
15.
backward.
Yeah.
Yes. Now. Okay. Check this out. This is they gave you a good one here. So what do you think you should do here
It's
first?
the a plus b a squared minus ab plus b squared. That thing, right?
Yes, but not quite right away. Why?
Oh.
Yeah, why?
Uh,
If you try to do it, you can't. I look careful. This one is like
yeah.
something that student tend to actually force it to work. You know when you do the A and the B, you might I think you were thinking A maybe is 2x literally, right? You know what I mean, something like that,
Mm-hmm.
right? It's not because why? Because it's not in the parentheses. Get it? So
Mm-hmm.
I know that you don't have to write in parentheses, but you should, but you can't do it yet anyway. But yeah, if you ever want to identify like the cubes and there's something more to it than in front of the x cubed or whatever
Oh wait,
y
you
cubed.
can't. Yeah, yeah, yeah.
Yeah, you
You
can't.
can't
Not
cube
yet. Not
anything.
yet.
That's
Not
why.
yet. But then what do you do if not? Yeah,
Then you just leave that and then do the bottom, right?
sure. But
I don't know.
but the bottom has something relating to the top. So okay, let me tell you, you you have to always look for a GCF at the top and the bottom every single time. So
The top and the bottom have a common factor of 2
yeah, so we
x.
factor the two. I'll write it up and above it, so we don't have to write too much. It'll be what two x to the cube plus 1. Okay, and the bottom would be
Mm-hmm.
2x squared minus 4x minus 5. Double check my math. Is that good?
Mm-hmm.
Okay, now you can actually do the difference of cubes. I know in my writing kind of
Okay. Oh, with the x squared and then the 1. Yeah.
wait, not squared, cubed, right?
Right?
It's
Oh,
still
is it
cubed.
cubed?
Yeah.
Oh.
Wait, do you want to think about it? You want to look at the problem again?
No, I get it. I think I get it. I think
Yeah,
I
it's
get it.
cubed. It's still cubed. I'm trying to
Yeah.
get my font a little bit bigger here. Yeah, it's just x cubed because I just factor out 2. So
Mm-hmm.
what you have left is going to have to still be cubed and 1. But then this now can be written as the a cubed b cubed. You
Mm-hmm.
know that? You can you see it? I even write it for you.
Yeah.
So watch. There, I forced the 1 to be 1 to the third because it's still going to be true. Therefore, your a is x, your b is 1. See that?
Mm-hmm.
But then how do you write it? Do you want to look at the formula? Do you need me to rewrite it or do you
Let's
think you
no,
remember it?
no, I have it right here.
Okay,
It's
so
gonna be x plus 1,
mhm.
and then x squared minus 1 or minus x plus 1.
Yep, that's it. Yeah, you got it. Now this can be done because x, but do you see why I can rewrite it as 1 cubed to make sure it's in that
Mm-hmm.
form? Like you can parenthesize it if you want, but yeah, your b is 1. You might not see the cube. You can force the cube to conform to the formula. This is it
Okay.
for the numerator, but the denominator. Oh yeah, don't forget. You can take out the 2's too right away. So you ignore it. It's done. It's okay. The 2's that you factor GCF is okay. Yeah, you don't want to look at them anymore. But then continue with the trinomial on the bottom because it's factorable.
Okay. Is it?
Yeah, it is.
Oh, it can be 5 and 1 or
Okay,
something.
5 and 1.
Yeah, it's gonna be x minus 5. Yeah, my x minus 5 and x plus 1.
Yep, that's it. And you see it matches this with the numerator, the x plus 1.
Yeah.
That's it. Yep, that's it. Now, remember, I was telling you, you might think, can this be factors further? No.
No,
Yeah,
yeah.
exactly. You're done with that. Yeah, it
And
might be
then it
tempting.
x can't be 5 and x can't be negative 1.
Yep, that's it. Got it. Yeah, you got this. You might want to rewrite what's left. Okay, some teacher don't like it. Just because you cross out doesn't mean that
No, I've
I'm
been
good.
doing that
Yes,
because I don't know.
this is
My
for
teachers
me.
like to stick with
Yeah, I can imagine. Many teachers don't like that. By the way, I'm just kind of for me like
why? I don't
okay.
know. It seems.
Yeah, I know. It's like, hey, show me the answer, not inside. The answer is in. I don't want to look for the answer inside. Like
Yeah.
the thing you
No,
worked
just
on.
like wait.
Yeah, so that's their.
14, I think is
All right.
next. Yeah, 14.
Okay. I'll copy the numerator, and there's nothing you can do.
Um,
Okay. I think you have an idea what to do here. I think, right?
um, factor first, so it'd have to be. Would it? I think it would just be 2m and 2m,
Okay.
or would
That
it be
okay.
4 and
It
m
will it will
and
be
1?
4m. It will be 4m plus
Okay.
5. But here's the thing. Now let me explain. Okay, let me explain. Since you're doing
Oh,
ration,
because there's another thing. Yes.
yes, but there's reason why. No, no, wait, look, there's something here I want to kind of point out. Had this not been, has this whole assignment not been anything relating to rational function with the fractions,
Mhm.
rational function, you trust me, you're likely to have this being 2m and then 2m. The good chance that chance being,
Oh, okay.
yeah, is that okay? So be aware. So they made this so that you're forced to use the odd combination in general based on my experience. It's likely going to work with the 2m and 2m. Okay, the one that's close to each other. But this is relating to rational functions. You kind of like have to go along with what they're actually intended for you to do. So anyway, what about the last two? That
It's
binomial
gonna be m plus 3.
plus 3. I think you got this. Let me double check. The outside is 12. Inside is 5. Yep, 7. Yeah, you got it. Okay, now what's the answer? What's the final answer?
1 over 1
Yeah,
plus 3.
that's the arrow of the other one, you see? Okay,
And
therefore, and the
the
restriction?
these are m can't be minus 5/4,
Yes, the other one?
and then m can't be negative 3.
Yes, that's it. You got it.
Okay, figure this out.
Very good, very good.
Okay, I mean, I think we can. Do you want to keep going? You
Yeah,
think
yeah, we have
want
time.
to keep
Just, yeah, let's, I
Oh,
want to
let's
look
do that one. Sure. 7. Easy or hard?
7. We did 7, right? Yeah.
Yeah, we did 7. Do you just want to do 12? I
Sure.
don't know,
Let's
they
do
get
12.
progressively harder, so it's gonna get
Yes.
progressively
Okay.
easier.
Yes. 12 is good. Yeah, I know. Huh? Well, actually, I don't know. It's kind of all over the place. Number 10 is like even
I
that
know.
one. Yeah. Okay, what do you think about 12?
Okay. Um, so it's uh hmm. Uh I'm gonna guess based on what you said, it's gonna be 8A.
Okay. Now, you,
Or no.
you got, okay. Believe it or not, you could probably do it. Like, likely, yeah, if you're gonna, but you're gonna expend a lot of energy trying to come up with the combination. It will work, by the way. It's always gonna
Okay.
work. Let
Okay.
me explain. You can do it, but you would rather do it after you pull out the GCF because it'll become smaller. Get it? You can deal with the
Mm,
smaller combination like numbers, right? The coefficient things. So yeah, believe it or not, you can do the 8A and make, or 1A and then maybe 4. Like you might be thinking I'll do 4A and something, and then 2A or something. Yeah, it's likely gonna work. But what happened with that is that inside here there'll be something you can pull out, like the GCF inside the. No kidding, there'll be a GCF inside the factors that you can pull out, and eventually it's gonna work. But you rather do it right
takes a
off the
while.
beginning, in the beginning, yes, because it will kind of speed things up afterwards. So what is GCF at the top? And look, if you do GCF on the top, might as well look at the GCF on the bottom because you do have it. So what do you think the GCF at the top is?
Um, GCF from the top?
Hmm. And
Ah,
what number or expression
oh,
with
8A.
wait, what I mean is this: what what is what is a number or expression that can actually be factored right away from the beginning that you can pull out the GCF?
Uh, 2 or
Okay,
4.
four is the, yeah,
4.
2 is the common factor, 4 is the greatest common factor. Yeah, you want to do the greatest common factor, so 4. So it'll be 4 2a 2a squared minus what is it 5a plus 2. Okay, same thing on the bottom. See, there we go, you got a 4
Okay.
and a 3a squared minus, oh, the bottom has a, sorry, you see it, the bottom has a.
Oh, yeah.
Yeah, 4a. The top does not have a, the bottom has 4a, so it'll be
So you
4a,
can't cancel it out.
oops, 4a and 3a, yeah, 3a and minus 2. Is that okay? Right there.
Mm-hmm.
And now you can, yeah, cancel out the 4, except the a is still on the bottom.
Mm-hmm.
Careful. Yep. Now you can start factoring. Wait, all I have is just 3a minus 2. That means the hint on top, one of them will be, we're looking at this, right? Oh,
Mm-hmm.
wait, double check the math here.
Mm,
I, okay, uh, double check the math. Let's do this one neatly.
right.
4a, everything is good, right? Yeah, 4. Because could you see what's happening? There is no, okay, this is a good problem. I think that let's how we keep trying to force something matching, in the denominator. You can't do that from here, right? But don't worry. Let's continue with it. It looks like we did everything correctly. So, but let's go ahead and come up with the combination. Ignore the denominator entirely. So, what do you think?
Okay.
So, what's
Um,
what's the combination do you want on top?
it's gonna have to be. Well, you said 4 and 2 would have to be factored again, so we'll just do 8 and 1, I guess.
Oh, wait, the 4 cancels out. So all you need to do is factor that, right? For the numerator.
Mm-hmm.
You follow? You already pull out the
Yeah.
4. That means you don't deal with 8 anymore. Because if you
Mm-hmm.
want to distribute it in, you get this thing back. Double check. Yeah. So 8 is no longer,
Mm-hmm.
yeah, you don't have to think about 8. But pretend this is brand new. How do you factor that in the numerator?
Uh, um, um, oh, um,
2a and
oh,
a.
'cause it's, oh, yeah, yeah, 'cause it's the new version, yeah.
Mm-hmm.
Yeah, yeah. So it's 2A, and then A, and then it's gonna be, um,
You got
uh,
2.
To get
2,
2, it's gonna
1.
be 2 and 1.
Is that okay? And then
Mm-hmm.
check. What about the signs?
They're both gonna be negative.
Okay, let's check. Would that work? Outer will be a negative 4a. Inner is negative 1a. Yeah, you get that. And then the last will be a positive 2. Is that okay?
Mm-hmm.
Well, it looks to me like this one, nothing cancels.
So is that just the answer?
Well, you still have to write the restriction. This will be the answer. Now you can keep
Okay.
it. Now you can keep it like this, or you can keep it as non-factored form over this not over the factored form on the bottom. Is that okay? It's up to you. Teacher won't
Mm-hmm.
care. But yeah, this is kind of weird because we've been able. But sometimes they have to actually challenge you and see if you always like see if you can handle it. But and now I'm like trying to check the
So
denominator carefully. So the
A
denominator,
can't be 0, and A
yeah,
can't be 4
a cannot be
thirds.
0
Or
and
negative,
two
or
thirds
yeah, 4
and yeah, exactly 2/3. You mean right?
2 thirds? Oh yeah, 2 thirds.
Yes. So this is the restriction and this is the answer. But I don't see that we did anything wrong. Double check the denominator. 4a times 3a, that's 12a squared. 4a times negative 2, that's negative 8a. So yeah, there's nothing. So this one, you only factor out the 4. So the final answer could be written like this, okay? You could leave, you don't have to write that factored one. Just leave the one that you got left up right here. Get it?
Okay.
Over this here on the bottom. Yeah, but fine.